Hello guys, I am going to describe you about hashing. Generally, hashing is used to reduce the time complexity or searching time of data elements. To know about hashing, firstly we have to know about why hashing is used and what are the searching techniques. Let us know about linear search. In linear search, um, when searching the key, all the keys are compared to one from index 0 to more, and if it is found then searching is complete. For example, if there are data elements in index 3, 4, 8, 9, 10, suppose in index 0, 1, 2, 3, 4, then searching will be done from index 0. The key is compared, the key which we have to search will be compared from starting to 0 and further index. So let us consider index 10, value 10, key 10, so that we have to search. Then searching will be done from index 0. If in key 10 exists in index 0, then search is complete. Similarly, searching is done. So if key is at the last of the array, then the worst time complexity of linear search will be ON. ON will be the time complexity for linear search. Similarly, for binary search is also another type of searching technique. In binary search, key is compared with middle value or middle key value of the array. But the most important point to know for binary search is that it should be sorted. In order to complete the search, the values should be sorted. At first the values should be sorted, and then searching will be possible. For example, let us consider the key values with 3, 4, 5, 6, 7, 8, 10, 16. Let us consider we have to search some key value, then it is compared with middle value of the list. For example, if we have to search, suppose 10 from here, then middle value is first compared with the key value we want to search. If the key value is less than the middle value, then left part is selected for searching. If it is greater, then right side is selected for searching. Since 10 is greater than 6, so we have to take this part for searching. And then um, similarly we do search in another part like previous method. Now if the key value is equal to mid value, then search is complete. Then if it is less than mid value, then left side is taken. If it is greater than mid value, then right side is taken. The complexity for binary search is O log n. O log n is the complexity for binary search. But to reduce the time complexity from O log n to O1, hashing strategy is used. Now let us start hashing. We can reduce time complexity of searching to nearly O1 by using the hashing algorithm. Now, the general idea of hashing is that for the list of elements and given array space, then we store the elements upon its own index. Suppose we have element 10, then we store that element 10 in index number 10. So if we have to find element 10, then we directly search to index 10, and if there is element we wanted to find, then search is complete. Then if it is not there, then the element is not found. So this reduces the time complexity from O log n binary search to O1 by using hashing technique. For example, let us consider 8, 3, 13, 5, 2, 10. These are the data elements. Then we have to arrange these elements in hash table. We have to arrange this element in hash table like we say this is key space and hash table. Let us consider 8, 3, 13, 5, 2, 10. These are key space, hash table. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have to store this 8 in index 8, 3 in index 3, 13 in index 13, 5 in index 5. Like this we can store the key elements in hash table according to their index value. But the main problem of hashing is that if we have to store, let us suppose we have to store element 70, then there is many gap between 10 and 70. Let us then here is a gap between 70 and 10 is 60. Now 60 areas will be unused during this technique. So we have to make more efficient by using hash function, by using other hash function, so that the memory is not wasted. It is the main problem during the hashing, but it is the initial phase. So now how can we solve this issue? Now let us consider hx equal x. This is the hash function that we used before, that the element are stored in hash table similar to the value of element. This is that function. Now we can modify this function as x equal x mod size of hash table. We can use this function to store the data element in hash table. Let us take some example. If element equal 3, if the element equal 3, then and hash table size equal 10, hash table size is 10 and element is 3, then hx will be 3 mod 10 equal 3, then it will be stored in index 3. Now similarly for element 9, hx would be 9 and it will be stored in index 9. But there can be issues even after using the hash function. Let us take example 13. Then if we take example 13, then hx would be 13 mod 10 is also 3. If there are element 3 and element 13, then we have to store both of the element in index 3. So there is collision between the elements. So there is possibility that 2 or more elements are mapped in the same index, which is called as collision. In order to solve this problem, we have to resolve the collision. There are different methods for avoiding collision. One is One is open hashing. One is open hashing and two is closed hashing. In open hashing, we can use chaining method. Now, in chaining method, hash function is same. In this case, we do not store the element in hash table itself, but we will add a new chain, and in that chain, we will insert the element. Chain is nothing but the linked list. So I will explain you with example. If 3 and 13 should be stored in index 0, 1, 2, 3, 4. If 3 and 13 should be stored in index 3, in this index, then we can resolve this collision by using chaining method. By linking them in a chain. By linking these elements in a chain in same index. Now we can store it like this: 3, 13. Now we can make the linked list in this index to avoid the collision and chain them in a index. Now this is very simple technique for in chaining is simple technique, open hashing. Now we can use closed hashing. There are two types of closed hashing. One is linear probing and another is quadratic probing. Now let us see linear probing. Linear probing. In this method, hash function is same, but whenever the collision occurs, key element will be stored in the next index, which is free. So if collision occurs, then we will store the element in next index, and if there is collision, then next index. Like this, we store the element. Now we can use this function hx equal x mod size and s dash x if collision occurs. S dash x means after collision has been occurred, then we use this function hx plus fi mod size, where fi equal I and I equal 0, 1, 2. For searching the element in hash table, like this we can now later I will make hash table also. Sorry for using this paper, I didn't found A4 size paper now and made video using this copy. Now we can store like this. Now let us suppose 0, 1, 2, 3, 4, 5. Now if 2 and 12 here 10, size is 10, suppose let us if we take size 10, then it will be easy for calculating hx. Now let us take 2 and 12, then there will be collision in index 2. So how can we do this? First of all, we store 2 in index 2. Now in case of 12 we there is collision, so we have to store that in the next index, which is free, that is index 3. Index 3 is free after that, so we have to store it in index 3. 12 will be stored in index 3. What if index 3 is already packed? Suppose 3, it is already packed and 12 came at last, then we have to go to next index, which is free, and no matter which index it would come in the way. So index 4 would be the right choice. Now, this is the linear probing linear probing, but for searching complexity will not be exactly O1 in this case, because we have to search for other index also, so it will be slightly more than O1, but it will be far less than O log n. So linear probing is also best. It is slightly more than O1 because of extra searching for other index. But the problem is, there is also a problem in linear probing. The problem is that it causes clustering element. That is, many element will be stored in consecutive cluster of indexes, and other clusters consecutive indexes will be free. So and now for searching in closed hashing, for searching the element in hash table, we first go to the index similar to the key. If it is not found, then we go to next index to it until empty is found. If empty is found, then it means that the key, there is no key in the hash table. If empty is index found, then there is no key element that we are searching. And similarly, quadratic probing is also not a different, but we use quadratic probing to to remove the effect of clustering in consecutive indexes. Bunch of element will be at one single place at consecutive location. They will be allocated continuously. So this may cause lot of time for searching any element. So to avoid the clustering of element, we introduce quadratic probing. Now quadratic probing is similar to linear probing, but only different is that hx equal x mod size as dex x equal hx plus fi mod size. The only difference is that fi equal I square, which prevents us to form a cluster in the hash table where I equal 0, 1, 2. Now quadratic probing is, this is quadratic probing. This is done to avoid the clustering effect. Thank you guys. If you have any questions, please mention it in a comment. I'll try to again describe it if there is problem, and sorry for bad video and bad copy. Thank you.